Hello and welcome. Today we're going to look at an interesting phenomenon about the circles of latitude on the Earth. By definition, the circles of latitude are equally spaced. And if we look at a diagram such as this one, taken from a Facebook page called Geography, they appear to be equally spaced. However, look at this. At 24 degrees, it looks like we're almost halfway to the North Pole. At 45 degrees, maybe we're 2/3, and at 60 degrees, instead of being 2/3, we're almost all the way to the North Pole. Well, why is that? The first thing we're going to do is turn the globe right side, so it's straight up and down. And then we're going to take away the outside of the globe and everything away except a circle of latitude and the equatorial circle, and we're going to color them in as we've done here. Then we're going to draw perpendicular lines between the two sets of circles. So we'll get these yellow lines, and we could draw as many as we want, and those are going to represent the distance from the equator. And of course, they're right angles. So what we're going to do is make a fraction whereby the numerator is the length of this segment, and the denominator is the length of the segment from the center of the Earth to the North Pole. Now bear in mind that equals to the radius of the Earth. We're going to use that. And we will do it as a percentage sometimes. So here we get this nice diagram. This is why math is easier than engineering. We've cut the Earth in half. Right now the circle, which is the equator, because we're looking straight at it, appears to be a straight line. And the particular latitude also appears to be a straight line. So as you recall, the yellow lines over here on the left are right angles. So we get this nice rectangle, which we can divide into two congruent triangles. And by definition, the yellow angle is 24 degrees. So that makes its alternate angle over there also 24 degrees. And that's the triangle that we're going to take a look at. So let's look at this triangle that goes from lat to cent-lat to CE. So that gives us, if we look at the ratio of from the center of the Earth to from the equator to the circle of latitude over the radius of the Earth, that turns out to be the opposite over the hypotenuse, which is the sine. So the answer to our question is the distance from the equator is always the sine of the latitude, which is straightforward enough. And as we can see, sine behaves like this, so that's why we cover more distance, apparently, in the early degrees than we do the closer we get to the North Pole. So thanks for watching that. There is one more video, companion video, that I hope you'll watch that will show some other interesting points about this phenomenon.